All right, guys, no time to waste. Open your formula sheets, your mobile phones. Mohammed, anything else that comes out of your mouth has to be related to physics. I'll be observing you. If you say anything else, tomorrow might not be such a good day for you. Your formula sheets, everyone.
Yeah.
Okay, I want you to look for this formula in your formula sheets.
Just a second.
Your second chapter.
P is equal to mv mass multiplied
By velocity, okay, so.
Okay.
Yes?
Yeah.
This is called the momentum, yes?
Okay.
Okay. Its units are kilogram meters per second.
Wait, I didn't see it.
You didn't see the formula, or you don't know the units?
I didn't see the
Oh, we have to write this down in our
P
formula.
is equal to
If you see it there, then you don't
Oh, I
have
saw
to.
it. Momentum and impulse.
Okay, yeah.
Momentum is not impulse. Impulse is the change in
No,
momentum.
it says
No,
momentum
under-
and impulse.
Mm. So you see this in your formula booklet. You should also know that its units are kilogram meters per second. Why are its units kilogram meters per second?
Because mass is kilogram.
Mass is kilograms. Velocity is meters per second. If you don't know the unit for anything, just look at the formula, find its basic units, and put them here. I told you this before. So let's have a bullet. Okay, it's this question is asking you, what is the linear momentum of a 4-gram NATO SS-109 bullet traveling at 950 meters per second? What is the momentum?
Find it? Find it?
Yeah, sure.
Okay.
I think you already did this problem before, but still this is like a recap.
Yeah.
3,800?
No, it's not.
No, it's not
What
3,800.
do you mean?
The key thing you should keep in mind here is,
Okay, gram make to kilogram.
yes,
0.4? 0.04.
3.8, 3.8, 3.8, what is it called?
Yeah, exactly what I said, no?
first you have to convert the grams into kilograms. It will be 0.04 kilograms. And using this and the formula and the velocity, which is 950, we find that the momentum is, Faris,
Yes.
what is the momentum?
Zero. This one 0.04.
No, this is the mass. You multiply the mass with the velocity,
0.8.
you will get the momentum. So it is 0.004 times 950, which is 3.8 kilogram meters per second. This is the momentum of the bullet. Now, this number might not mean much, and you might not understand what this is for now, but you will understand what.
So what is momentum?
Momentum is the mass multiplied by its velocity. It's the amount of motion that is there in an object. A big object with a big velocity has a lot of motion. A small object with a big velocity has motion but not as much. Consider the object as the amount of particles inside the object. So you see this object? It has some particles inside it. Consider all these particles moving. Okay, V, 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 V. If this is one particle, it's moving with V, velocity V. This is also another particle moving with velocity V. You add all of this up, you will get momentum, mv. M is basically the mass. You understand? Think of it like this. If you have a small object and it's moving with velocity v,
Velocity is basically speed and this one direction.
speed with direction.
Speed with direction.
So let's say my velocity is 10 meters per second. Okay? I have a small object which is 10 kg traveling at 10 meters per second. Okay? The amount of motion inside the object, you will say it is mv, which is 100 kg meters per second. But if you have a big object, okay, traveling at the same speed, let's say you have a big object, but its mass is 100 kg, it means it has more particles inside. So the amount of motion inside the object is more. How much more? By 100 times 10, which is 1000 kg meters per second. It's 10 times more than this. So the amount of motion in this object is more than the amount of motion in this object, even if they're traveling with the same velocity, because there are more particles here. That's why there's more motion in this object. Do you understand? That is momentum. The amount of motion inside an object. So this is the amount of motion inside the bullet. Okay? So bullet is very small. That's why the amount of motion is small. But it has a lot of velocity. Imagine a big object like a jet aircraft traveling at this speed. It'll have a lot of motion in it. So obviously its momentum is more than that of a bullet. Do you understand the concept of momentum?
Yes.
Okay. Making a few tweaks, I got this formula. F net is equal to delta P by delta T. You don't need to understand how I got this formula, but if you want, you can have a look at this conversion. But in the end, I got this formula. F net, which is the net force on any object, is the change in momentum by the change in time. If I want to write this in terms of words, how do I write it? Remember, delta T divided by delta T is nothing but the rate. Right? So how do I express this in words?
Rate of momentum.
Rate of?
Momentum. Change in momentum.
Very good. Rate of change in momentum is?
The
Force.
F.
Total force.
The total force. So the total force in any object is the rate of change of momentum. Okay? So let's do an example about that. Read the question. Tell me what are the variables that you see? Like what is my m, what is my v, anything that you can see here. I will write it down.
Mass is 16.
Mass is 6, very good. Anything else?
Velocity is 25.
25?
No, 5.
Is it 25 or 5?
It goes from 5 to 25.
It goes from 5 to 25.
In 30 seconds.
So
time
5
is
is initial velocity, I think.
30 seconds. Is it time or delta time? Change in time.
Delta time.
Change in time is 30 seconds.
30 seconds. Okay.
What do you
sir.
see here? Velocity is changing.
Velocity.
When the velocity is changing for the same mass, what do you think the motion of the object is happening to the motion of the object? Is it decreasing or increasing?
Decreasing.
It's decreasing, right?
Decreasing.
Increasing? How?
It's
Or is it increasing?
Increasing, yeah.
Oh, so it goes from 5 to 25. So it goes like this. So the motion of the object is increasing.
Increasing.
By how much is the motion of the object increasing?
By
20.
Delta P is equal to?
20.
No, it has to be 6 multiplied by 25 minus 5.
This is the, this is the initial, wait. Delta P is equal to P final minus P initial. What is my P final?
P final is 6 times 25.
6 times
25.
25. What is my P initial?
6
6
times
times
5.
5.
So what is my delta P? Simplifying this.
So 150 minus 30, you get 120.
120
120, what is it called?
Meters.
kg meters per second. Any questions here?
No.
So this is my change in momentum. Faris, do you understand how I got this?
Yes.
Which formula did I use? Did I use this formula or this formula to get this?
Second.
No, obviously I use the first formula.
What?
First formula states that change in the momentum is given by mass times velocity. This is the final momentum. This is the initial momentum. Final momentum is mass times final velocity. This is my final velocity. Initial momentum is mass times initial velocity. This is my initial velocity. So what is my change in momentum? This minus this. Simplify, I will get this. What does this delta stand for? Change in, what does this P stand for?
Moment.
Momentum. What is momentum?
This equation.
No. Tell it to me in terms of how you see the motion in an
Yeah,
object.
you said mass, I think.
Yes.
Sir, the mass multiplied by velocity.
Okay. What does it mean?
Sir, like the motion of the object.
The motion of the object. The amount of motion inside an object. The more the mass, the more the motion.
The more the motion.
The more the velocity, the more the motion. Okay. So momentum is given by mass times velocity. Change in momentum is final momentum minus initial momentum. How do you get these values?
Sir, changing anything is like
Final minus initial.
final.
Change in time, final time minus initial time. Change in Zubaida, final Zubaida minus initial Zubaida. It's like that.
So the reason why we know there's a change in momentum because the velocity changed from
Exactly.
seconds, right?
The motion changes
Yeah.
because you know that the velocity changes.
Yeah.
So if the velocity changes or the mass changes,
Mm.
the motion changes.
Okay, so we don't take time into factor. We know that.
Not yet.
Not yet. Okay.
Okay? So you know the change in momentum, but you know the change in time also. The question is asking you what is the net force? You know this.
Oh.
You know this.
Okay.
So how do you find the net force?
We divide the change in momentum with the change in time.
Change in momentum by
Change in time.
change in time,
That's the net force.
which is 120 by 30, which is
120.
120.
120 by 30, which is
120 by 30.
4.
4. So, and what is that for? What are the units?
Joules.
What are the units for force?
Newtons.
Newtons.
Sir, why do I feel nothing? Oh, okay.
Sophian, did you understand this?
Yeah.
I thought we are just finding the change in momentum.
Are we?
Yeah, no, just now.
Mohammed Manaf? What are we trying to find here?
Net force.
Okay, how do we find the net force?
By using the second equation.
By using the second equation.
Yeah.
Sir,
Okay, good. Now, how do I find my delta P?
Delta P.
What is my delta P? Faris, you can help him.
6 kg.
Oh my god.
sir.
Wait.
I have a question, sir. How we got 30? Sir,
Yeah.
5, the initial.
Wait, Mr.
See,
Salim.
sir.
Hmm.
We have to find the initial and the final
Oh, it's great.
velocity.
What does P stand for?
Just now you said momentum.
Momentum.
Yeah.
So, what am I trying to find?
The initial velocity.
Is this velocity?
No.
Ah.
Momentum.
Yeah, the initial momentum. And the
Final momentum.
Yeah.
Very good. So, how did we find the change in momentum? By subtracting initial and final momentums. How do I get the momentum, final and initial? What is this? What is this?
Yeah, we
Like the way you did it.
yeah we'll do like the mass into the speed.
Very good. Mass times velocity minus mass times velocity. It'll give you the change in momentum. And where did we use this?
Then we'll divide with the time. This one.
Time,
Yeah.
which is this.
So we'll divide the momentum with the time.
Yes. So if they ask you for the net force,
And we'll get the net force.
exactly. Was that so difficult, Faris?
No.
You can do this in the exam.
Because I don't pay attention, so that's
Okay, now you are.
yeah.
Keep this up. I'm going to ask you questions. Okay. So the net force is 4, not 40 newtons. It's 4 newtons. Because the units of force are? The units of force are? The unit of force is? Newton. The unit of momentum is? Very good. Good. Fantastic. Next. Now, there's another formula. Wait, was this formula in your formula booklet?
Yes, boss.
Can you check if this is in your formula booklet?
Yes, it's it.
Yes, it is.
Okay.
What is the
Now check if This is in your formula booklet.
Yeah. it
Kinetic energy is P squared by 2m. Is it there?
is. Yes.
Can you check?
Yes.
Can you check?
It is.
Yeah, it's there.
It is there? Okay.
Mustafa, what the hell?
It is. Yeah.
Can someone remind me
I'm
what
pretty sure he
Yeah.
memorized everything? Okay.
Yeah.
What is kinetic energy?
So why two formulas for kinetic energy?
They're the same thing.
Really?
Yeah, what is my P?
Principle.
It's MV.
Momentum.
P is momentum. What is my formula for momentum?
Oh, okay.
mv. If I substitute mv here, I will get the same formula.
So we have to choose if we have momentum, we can find this formula, or if we have this one, mass, velocity.
You have velocity, use this formula. If you have momentum, you use this
Sorry,
one.
that's the old formula.
This is the old formula.
Yeah, the original.
Power is equal to-
You mean this one?
No.
No.
This one, yes.
Yeah.
This is the original formula, the old formula of kinetic
Why we
energy.
changed it to this one?
Because sometimes in the question I won't give you the velocity. I'll give you only the momentum.
Alright.
You should see what I gave you.
So we divide
Like
that
cos
by m
2r.
because we're multiplying the whole thing by to the power of 2, right?
Yeah,
Okay, then the 2, why is there a 2?
because it's half.
How does that come to be a... Oh, okay.
Any other questions?
Well, why did you raise it?
You don't need to understand that. That's not important. What's important is you have this formula. And this formula is the same as this formula. They're both the same. And what are they calculating?
The kinetic energy.
And what is the kinetic energy?
It is
Energy in a body.
energy which is
In a
after the
moving
potential
body.
energy.
When does the body have kinetic energy?
When it's moving up.
Exactly. When a body moves, when it has velocity, it has
Kinetic energy.
kinetic energy. When does the body have potential energy, Faris?
Wait. What's the question?
When does the body have potential energy?
When it's moving.
No. When it's moving, it has kinetic energy because of the velocity.
Okay.
But when does it have potential energy?
When it's about to move.
No.
Okay.
Yeah.
When it's stationary.
Yeah.
Okay. When it has a height.
Yes, you said.
When an object has a height, it has potential energy. But when it starts to move, it gets kinetic energy. Okay. What is the formula for potential energy? Can someone remind me?
Potential energy.
MGH.
I'll give you a hint. It has the height in it.
MGH.
mgh is the potential energy.
What the map saying?
That's a joke.
Right. I have this question here, also an IB question, only a part of it. What is the kinetic energy of a 4-gram bullet traveling at 950 meters per second square and having it this much momentum? What is the kinetic energy?
We can find it in the 2 ways.
Exactly, very good. Which formula would you use here, Faris?
Wait.
To find, what are we trying to find here?
The kinetic energy.
The kinetic energy.
Yeah, so we use the P2 divided by
P square by 2m. Do you have the momentum? Do you have the P? Momentum?
Yes.
Yeah, we have.
You have momentum. Okay, you have the P. Do you have the mass?
Yes.
You have the mass.
Yeah.
So can you find the kinetic energy? Okay, just substitute and you will get the kinetic energy. But before we substitute the mass, what should we do?
To kgs at 0.00.
Change it to kgs, which is
Yeah.
0.004.
So the formula is 3.8 squared over
2 multiplied by
3.8 square
Okay.
by 2 times 0.04.
Okay.
You will get 1800 joules. And what is this?
kinetic energy.
The kinetic energy of what?
Of the bullet.
The bullet.
Of the bullet. So imagine this to be a soda. Like, you know, sodas have how many calories? 300 or 200 calories. So, and each calorie is 4 joules. So, which means a can of soda is 800 joules, I think. So, how many cans of soda do you think this
This
has?
is, you divide it, you get 1.
This is also,
Wait, explosion is when
This
two
one is,
objects go
sir-
away from each other.
Sir, this
Collision
one
with
is
two objects.
cosmic collision.
obviously, it's because it's cosmic collision, yes. Between two galaxies. You know how two galaxies collide?
Yes.
Oh.
Do you know what is at the center of each galaxy?
Yes,
Black
black
hole.
hole.
Black hole. So when two galaxies collide, it's
They
because
make a huge black hole.
they make a bigger black hole. Yes, and sometimes one of the black hole takes some of the stars along
Yes,
with it.
pulls them.
Yes. Why do the galaxies collide? Can someone tell me?
They are
Gravitational.
They attract each other.
Gravitational waves.
They attract each other.
Attract
Because
each
of the
other?
gravity, no?
Because of the gravity of what?
the black hole.
Oh,
The black hole. Very good.
Okay.
So the center, it pulls the galaxies together, and sometimes they collide, and sometimes they give out lots of energy, particles like this. This is called a nebula. Nebula is basically gases spread out because of collision between two. You know, when two objects collide with a lot of force, they just split apart into small things, and that releases gases.
So how fast, if we could actually see two galaxies colliding, how fast would it be?
To us, it seems like they're moving very slowly, but then if you go near them, it'll be even faster than the speed of light.
Very fast.
Yeah.
Faster than the speed of light.
Isn't that relativity?
See, although our collision, the collision that I talked about, that is relativity. Even though the collision that we have on Earth between two balls or two objects, the amount of time it takes for that collision is very small, right? You see two objects coming, the time it takes for a collision in the middle, it's small. You have two balls, they collide and then they separate.
Yeah.
What do you think is the time which they stay contact? It's very little.
Yeah.
It's a small time that they stay in
0.1
contact.
seconds.
But when it comes to galaxies, they actually collide for a long time. You have like,
So they will stick together.
they're not sticking together. It's just that you observe things. Their lifespan is totally different compared to the lifespan of this, because they're big galaxies. When they collide, it takes a long time for you to, I mean, when you
finish the collision.
finish the
Because
collision.
From behind also they take this.
Yes, like that. And then when you're a kid, like when you're born, they probably start colliding. And even when you're dying, they didn't finish the collision yet.
Ooh.
You understand? They're like that. Galaxies are huge. Their time is totally different.
So there
Compare.
is some galaxy now in the space are colliding.
Obviously, there are so
From
many galaxies.
1990 something.
From what? Millions of years ago, they're still colliding till now.
That's
So.
scary.
Our galaxy Milky Way is collide with Andromeda in like 7 billion years.
Yes, our own galaxy is going to collide in 7 billion years.
That's all.
We are not going to be here.
It was relaxed.
Huh?
Oh, what do you think this is?
Alpha particle.
The alpha particle nucleus is the.
So what do you think is an alpha particle? Is it the blue one or the red
It's
one?
like the
It's
main
the
particle.
blue one.
The B particle.
Blue one is the. What is it called?
Really, it's called B, no?
Yeah, it's
Wait,
blue.
or
Red is
gamma.
nucleus.
Very good. Beta, gamma, yes. Those are also particles, but this is the alpha particle. Okay, there are also different types of particles. So what do you think is an alpha particle?
The main particle.
Yeah, what is it called? The radiation?
Yeah.
Wait.
I'm not going to go into detail anyway. Alpha
It
particle
can
is...
pass through this.
It has a very short wavelength.
Yes.
Have you seen positive charged particles?
Yeah, I've seen them.
Alpha particles are made of positive charged particles. Okay?
Yeah.
So they're basically rays of positive charged particles.
Yes, that's why when they go next to nucleus, they go out to the other way.
Very good. Because the
Okay, I know.
nucleus is positively charged. When a positive charge comes towards positive charge here, the nucleus goes here, the alpha particle. Because positive repel.
Yes,
Repel each other. So this is also an example of a collision. So what is a collision? It is an event where a strong force acts on two or more bodies for a very short time. And this short time is relativistic. For galaxies, short is obviously different than the short time that we experience on Earth. Okay? So even that is a collision. This is also a collision. This is also a collision. This is even shorter than the collision that we see between the balls.
Oh.
Okay, it just happens like that. Okay? We will continue in the next class. Is the time over? Is the period over? Because I see some students.
We have time. I think we have time.
10:38?
Sure.
2 minutes.
Yeah, come on. Let's continue.
Yeah.
كلمة راح هذه يبيها.
Oh, did you know like what they found from this collision?
What?
What do you think they found, Zubaida?
Wait, found by like you mean like what gas they found? Or
No,
like
not
what?
gas. What did they found about the structure of an atom?
The structure, yeah, the structure is pretty complicated.
Let's imagine this is an atom, okay? This is an atom. And there is something in the center here. And they put alpha particles.
There is something more smaller than the nucleus.
You mean quarks?
They found that the center of an atom is a nucleus. That is what they found because they scattered many alpha particles. But when the alpha particles pass through here, nothing happens to the alpha particles. But when the alpha particles hit this,
Through, so there is no charge here.
exactly. But when they hit this, alpha particle went like this. Or sorry, the nucleus went like this.
Yeah, when it hits the middle, it goes repel. But when
Yes.
it hits the other side, it's fine.
Exactly.
It's fine. Switch on.
So they found the structure of the atom by using this collision. This is how they see or they find out things which are too small for us to see through experiments like this. Anyway, we'll continue in the next class. Thank you.